Okay. Do you have any doubt from the previous topic?
No, sir.
No doubt.
Sir.
Okay. So, Medhavika, what is hydration?
And the when the molecule is surrounded by H2
Molecules or ions surrounded by water molecules?
ions.
Ions surrounded by okay. So, with hydration, okay, tell me lithium chloride or sodium chloride. Out of these two, which will have more conductance in the molten state? Akshat.
Lithium chloride.
Akshat, I can't hear you.
Lithium chloride.
Lithium chloride. Okay. And the aqueous medium, Ashwin?
Sir, sodium chloride.
Why so?
NaCl.
Why so?
Sir, because due to hydration, the radius of hydrated lithium will be less as compared to the radius of hydrated sodium ion. Therefore,
Repeat. I think there's something wrong. Could you please repeat?
Sir, yes, sir. Sir, radius of hydrated sodium ion will be more due to which.
No. Here you have gone wrong.
No, sir, lithium will be more due to which its bulkiness will increase, mobility will decrease, and hence conduction will also decrease.
Okay. So, Medhavika, why lithium is more hydrated as compared to sodium ion?
Because when we look at the group, lithium is like in a higher placement than sodium.
Getting. Yes, Akshat, why lithium is more hydrated than sodium ion?
Sir, due to small size of the lithium ion,
What happens with the
it
small
is,
size? What happens with small size?
sir, then according to Coulomb's law, the distance is less, so the force of attraction is more.
I can say due to small size, it is a high charge density, right?
Yes.
More charge density means more attraction for water molecules. Okay.
Yes.
Excuse me, sir.
Yes, Ashwin.
Sir, due to small size, can we say it is also according to Fajang's rule?
See, Fazan rule is used to explain the covalency. Small cation has high polarizing power, and that makes more covalent bond, right?
Okay, sir.
But here, the ion is to interact with the water molecule. So here we require the charge density. Falcon, can you hear me?
Yes, sir.
Video on.
Okay, sir.
Yes, Falcon. Now tell me. What is the effect of
Yes, sir.
what is the effect of dilution on conductance of weak electrolyte?
Sir, conductance will increase
Reason.
in weak electrolytes
Reason.
because uh, Sir, because more ionization, because more ionization will be there, more ions will be formed, and number of charge is also more, so the conductance will be also more.
Good, good. Number of charge carriers will be more, right?
Yes, sir.
Good. Medhavika, effect of temperature on weak electrolyte.
I'm not sure about.
Not sure? Akshat will tell.
Sir, weak electrolytes are endothermic in the forward process, the forward direction. So when temperature is increased, according to Le Chatelier's principle, endothermic reactions are favored by high temperature.
Good.
So when the temperature is increased, number of ions will increase, number of charge carriers will increase, so the mobility will increase and hence the conductivity.
Right. So with rise in temperature, weak electrolyte dissociate more, right?
Yes.
Degree of ionization increases, number of charge carriers increases, so the conductance will increase, right?
Yes.
Okay. Any doubt from the previous topic, Palkin?
No, sir.
Okay. Ashwin,
No, sir.
Medhavika, you tell me if you have any doubt, anything you want to ask.
I didn't really understand the temperature part, the subtopic.
Okay, I'll discuss it. Okay. I'm sharing my screen. I'll explain that part again.
Excuse me, sir.
Yes, Ashwin.
Sir, I have one doubt from solubility chapter. Solutions chapter.
Okay, wait. Let me complete this, then I come to your doubt.
Okay, sir.
Yeah. If we have a weak electrolyte, let it be a acetic acid. It dissociates to give acetate ion and H positive. Medhavika, you tell me, this dissociation process is endothermic or exothermic?
Endothermic.
Okay. What do you mean by the word endothermic?
That energy is required.
Energy required to make ions, right? And the backward reaction is exothermic, right? So, according to the Le Chatelier principle, suppose I'll come to principle again. I'm providing heat. Okay? I'm rising the temperature. I'm providing some heat. Which process will take place? Endothermic or exothermic?
Endothermic.
Repeat this.
Endothermic.
Endothermic. So, according to the Le Chatelier principle, high temperature favors endothermic reaction. If it is favoring the endothermic, this equilibrium will shift in the forward direction. Right? This will shift in the forward direction. If it goes in the forward direction, what will happen? Number of ions will increase. Yes or no?
Yes.
I can say number of charge carriers will increase.
Yes.
If number of charge carriers increases, the conductance will increase.
Yes.
That's it, very simple. Am I clear?
Yes.
And now if you have a strong electrolyte, this is completely dissociated whether temperature is low or high. Now, in this case, with rising temperature, number of ions are not going to increase. They are already dissociated. So my question is, what is the effect of the temperature on the strong electrolyte conductance? I'll explain why also. Akshat will tell.
Sir, as the temperature is increased, the kinetic energy of ions will increase.
Okay. The kinetic energy will increase, right?
Yes.
So I can say their zigzag motion will increase, Brownian motion will
Yes.
increase,
Yes.
mobility will increase, and that leads to the increase in the conductance. Right? Getting it, Palken?
Yes.
Palken, are you there? Palken, the picture is static. Now, next part. Today's topic. Write on today's topic, specific conductance. Specific conductance. You know, in physics, resistance is directly proportional to the length of the conductor and inversely proportional to the area of the conductor. Yes or no?
Yes.
Yes, sir.
It is equal to resistivity into L upon A. So resistivity is equal to R into A upon L. Okay. Now, if I make the inverse of resistivity, I will get specific conductivity or specific conductance, kappa. This is denoted by kappa. Now it is equal to 1 upon R into L upon A. One upon R into L upon A. Understood?
Yes.
Yes, sir.
This kappa is called specific conductance. L upon A is called cell constant. And 1 upon R is the inverse of the resistance, or I can say it is equal to the conductance. So I can say kappa is equal to conductance multiplied by the cell constant. multiplied by cell constant. Am I clear?
Yes.
Right.
Yes, sir.
Noted on everyone? Vitalika?
Yes.
Right. Now let us try to understand what is the physical meaning of this conductance. It is equal to conductance into cell constant. Cell constant is L upon A. If L is equal to 1 centimeter and A is equal to 1 square centimeter, then the kappa is equal to conductance.
Yes.
Yes, sir.
Now let us try to understand the physical meaning here. The one that we are doing now is all mathematical. Now let us try to understand the physical meaning of these are the two plates that have been separated by 1 centimeter. An area of cross section 1 square centimeter. Area of cross section is 1 square centimeter. And the distance between the two electrodes is 1 centimeter. And in between the two, I have some ions. What I'm doing is I'm passing the current. The ions will move towards oppositely charged electrodes and the conductance will take place. What conductance will be observed in this 1 cubic centimeter due to all the ions present between two electrodes separated by 1 centimeter and area cross section 1 square centimeter, that is called the kappa, that is called a specific conductance. Right? So write down a definition of the kappa, specific conductance. It is the conductance due to all the ions. Write down. It is the conductance due to all the ions present between two electrodes separated by 1 centimeter and area of cross section 1 square centimeter and area of cross section 1 square centimeter. Right? Getting me?
Yes.
So
Yes.
in this diagram, I can say all the ions are there which have been placed between two electrodes separated by 1 centimeter and area cross section 1 square centimeter. What conductance will be observed? That is called as a specific conductance. So kappa is equal to conductance into cell constant. Kappa is equal to 1 upon R into L upon A. Now let us talk about the units. Do you know the meaning of the unit of resistance?
Ohm.
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 Ohm. Unit of length, centimeter. Unit of area, centimeter square. So it is now ohm inverse centimeter inverse. So the kappa unit is ohm inverse centimeter inverse. Ohm inverse, centimeter inverse. Getting my Ashwin?
Yes, sir.
Right. Ohm inverse is also called as a Moho. The Moho-Simon centimeter inverse. It is also called Simon centimeter square. S centimeters inverse. Understood?
Yes.
Yes,
Okay.
sir.
Between two electrodes, whatever the concentration is, all the ions are there. It does not depend upon the concentration, right? Whatever the concentration, all the ions. Now next topic write down molar conductance. Molar conductance. Write down. It is the conductance due to all the ions produced from 1 mole of electrolyte. All the ions produced from 1 mole of electrolyte placed between two electrodes and area of cross section is so large that whole of the solution is contained between the two. Note it down, then I will make it clear by the diagram. Right, Ashwin? Yes, Ashwin, clear?
Yes, sir.
Now, understand here. If I say I have 1 mole of electrolyte, suppose I have 1 mole of NaCl, can you tell me what is its weight? Can you tell me what is its weight? Weight of 1 mole of electrolyte, NaCl.
58.
58.5 grams, right? Atomic weight 23 plus 35.5. Can we store this much weight in 1 cubic centimeter? Can we store 58.5 grams in 1 cubic centimeter? Yes or no?
Yes.
Yes or no?
Yes, sir.
No, 1 cubic centimeter is too small size. 15.5 gram is a big volume. Now, if I say 1 mole of electrolyte can be contained in this 1 cubic centimeter, if let it be, then the molar conductance will be equal to the specific conductance. Because we know that specific conductance is the conductance in 1 cubic centimeter. If 1 mole of electrolyte is contained in 1 cubic centimeter, then the molar conductance and the specific conductance will be the same. But suppose it cannot be fit between two electrodes. It cannot completely fit between the two electrodes. The distance to be maintained as 1 centimeter, but you can increase the surface area so that the total volume can increase. So surface area should be so large that whole of the salt should be contained between the two electrodes. It means now we have to multiply with the volume V. Understood?
Can
Yes,
you
sir.
please explain once?
अश्विन ऐसा समझेंगे, अगर 1 मोल इलेक्ट्रोलाइट 1 क्यूबिक सेंटीमीटर में फिट हो जाता, तो उस केस में मोलर कंडक्टेंस और वॉल्यूम, मोलर कंडक्टेंस और स्पेसिफिक कंडक्टेंस दोनों बराबर होते.
Okay, sir.
क्यों बराबर होते? बिकॉज स्पेसिफिक कंडक्टेंस इज द कंडक्टेंस इन 1 क्यूबिक सेंटीमीटर.
Yes, sir.
अगर से पैक हो सकते थे तो मोलर कंडक्टेंस एंड मोलर स्पेसिफिक कंडक्टेंस वुड बी इक्वल. लेकिन अगर नहीं हो सकते हैं, देन इन दैट केस कीप द डिस्टेंस बिटवीन टू इलेक्ट्रोड 1 सेंटीमीटर, but increase the surface area so large that whole of the electrolyte is contained between the two electrodes.
Okay, sir.
Now, in that case, this is the volume. How many times you are increasing the volume? Multiply with that one.
Okay, sir.
No. We know that molarity, number of moles upon volume in milliliter, multiply by 1000. The number of moles means molarity into volume upon 1000, right? Kappa into, what is one? Sorry. We put in number of moles equal to 1, so I can say volume is equal to 1000 upon molarity, because putting the n is equal to 1 also. Am I clear?
Yes, sir.
So based upon this formula, we will have numericals. Any doubts?
No, sir. Sir, please show the definition once.
Note down the definition.
Done, sir. Thank you.
अश्विन, आपने कुछ पूछना था सॉल्यूशन चैप्टर से?
Yes, sir. Yes, sir.
बोलिए.
Sir, there is one question. Identify phenol will be insoluble, partially soluble, or soluble in water.
Phenol will be
Sir,
soluble in
phenol.
water. Soluble in water.
Sir, but there it is written partially soluble. Sir, because they have written OH is soluble, but the aromatic compound
yeah.
C6H5.
Yes. It is soluble but less soluble, because ये वाला जो part है, this is non-polar, और जो ये वाला part है, ये वाला part polar. इस polarity के कारण water में dissolubility आएगी, but इसके कारण नॉन पोलर पार्ट के कारण solubility कम होगी.
Okay, sir.
So it is partially soluble. You are right.
Okay, sir.
Anything else?
No, sir.
ये चैप्टर स्कूल में हो गया बतावे का?
School hasn't reopened yet.
There's no any syllabus going on. No syllabus going on. Great. Shut about you.
Yes.
ये चैप्टर नहीं हुआ अभी. Ashmin?
Sir, solution is going on.
सॉल्यूशन चैप्टर आप आता है सबको बतावे का?
Yes, sir.
Yes.
Yes.
एशमिन स्कूल में तो फिर आप जॉब देते होंगे अच्छे से?
Yes, sir.
स्कूल में परफॉर्मेंस अच्छी हो जानी चाहिए.
Yes, sir.
चलो आगे से. अच्छा, मोलर कंडक्टेंस में कोई डाउट है?
No, sir.
It's equal to kappa into 1000 upon molarity. तो kappa का यूनिट क्या था? साइमन सेंटीमीटर इनवर्स. और ये आ गया नीचे मोल्स पर लीटर. आई कैन से साइमन सेंटीमीटर इनवर्स मोल -1 लीटर. राइट. This is the SI unit. It is the unit of the molar conductance. Note it down. Any doubt?
No, sir.
No, sir.
Next, write down equivalent conductance. Equivalent conductance. In this definition, make one change on 1 gram equivalent. Rest all is same. Conductance due to all the ions produced from 1 gram equivalent of electrolyte placed between two electrodes separated by 1 centimeter. An area of cross section so large that whole of the solution contained within a tube. ओनली एक चेंज करना है. पहले मैंने आपको मोल कहा था, 1 मोल डिसॉल्व करना है. और इस केस में आपको कह रहा हूँ कि 1 ग्राम इक्वलेंट डिसॉल्व. नोट डाउन द डेफिनेशन वर्ड इक्विवेलेंट कंडक्टेंस. Note it down. Note it down. फिर लेंगे.
Yes, sir.
Yes, sir.
Yes.
तो we represent this mole equivalent conductance as lambda A cube. If 1 gram equivalent is contained in 1 cubic centimeter, then I can say specific conductance and the equivalent conductance would be same. Yes or no?
Yes.
लेकिन
Yes, sir.
अगर उसका वॉल्यूम 1 क्यूबिक सेंटीमीटर से ज्यादा होता है, then we have to increase the volume. So multiply by the volume. And we know that 1 gram equivalent comes from the normality equation. Normality is equal to number of gram equivalent upon volume. Milliliter multiplied by 1000. So volume is equal to number of gram equivalent upon normality. ये equivalent हमने put करने हैं 1. So kappa into 1000 upon normality. Yes or no?
Yes.
Note of the formula.
Sir.
तो मैंने आपको 3 फॉर्मूला दिए हैं, इक्विवेलेंट कंडक्टेंस, मोलर कंडक्टेंस एंड सिंपली कंडक्टेंस, स्पेसिफिक कंडक्टेंस। इन तीनों फॉर्मूला में कोई डाउट है?
No, sir.
यहाँ तक कोई डाउट है किसी को?
No, sir.
No,
No, sir.
ओके, इन 3 फॉर्मूला पर न्यूमेरिकल प्रैक्टिस करना। बुक में सॉल्व अनसॉल्व दोनों दिए हुए, राइट?
Yes.
5 क्वेश्चन ऑन ईच टॉपिक, ईच फॉर्मूला। दैट इज योर होमवर्क एंड सेंड इट बिफोर द नेक्स्ट क्लास। ओके, कर सकते हैं सर?
Yes.
मेधावी का?
Yes, sir.
राइट। चलो अब आगे चलते हैं। देखिए नेक्स्ट टॉपिक, वेरिएशन ऑफ मोलर कंडक्टेंस विद dilution. Make one change here. Variation of molar conductance, specific conductance and equivalent conductance with dilution. तीनों पर फर्क पड़ता है, देखते हैं। हेलो,
Yes.
Yes, sir.
ओके, इतना होमवर्क करके आ जाएंगे,
Yes.
राइट?
Yes, sir.
हमारी जो कल की क्लास होगी वो भी 9:30 पर ही होगी, राइट?
Yes.
तो कमेंट 9:30 होगी। हाँ अश्विन बोलिए, राइट?
मैंने कहा
तो
okay, sir. Yes.
तो मैं मैसेज दे भी सकता हूँ ग्रुप में और नहीं भी दे सकता, डिपेंडिंग अपॉन द टाइम अवेलेबल। अदरवाइज कीप इन माइंड दैट टुमारो क्लास इज एट 9:30, राइट?
Yes.
नाउ सबसे पहले डिस्कस करते हैं इफेक्ट ऑफ डाइल्यूशन ऑन द कैपा। व्हाट इज कैपा? Specific conductance. Specific conductance is the conductance due to the all ions which are present in 1 cubic centimeter. इस 1 cubic centimeter में जितने भी आइंस हैं, लेट इट बी आपके पास में यहाँ पर 1000 आइंस है, हमने एक बड़ा बीकर लिया, इसके कंटेंट को इसमें शिफ्ट किया एंड इसके बाद वाटर ऐड कर दिया. These ions जो कि 1 cubic centimeter में थे, now they will all scattered in this more volume. Yes or no?
Yes.
Now
Yes,
you what you
sir.
do is you take out 1 ml from here and pass it back to the electrolytic cell. क्या अब आपके पास 1000 ions आएंगे? Yes or no? इसमें से 1 cubic centimeter सोल्यूशन निकालो, इसमें पुट कर दो. क्या अब यहाँ पर 1000 आइंस हैं या नहीं है?
No, sir.
No. Less or more?
Less.
Less.
Yes.
If number of charge carried decreases, the conductance will
Decrease.
Decrease.
So I can say the kappa decreases with dilution because number of ions per cubic centimeter decreases. Because number of ions per cubic centimeter decreases. Yes or no?
Yes.
Yes, sir.
Now, molar conductance. Kappa into volume V. The kappa value decreases. मैंने अभी डिस्कस किया. But the volume increases. Dilution करेंगे तो volume बढ़ेगा. And increase in volume is much more than the decrease in kappa. Therefore, overall lambda m increases. So molar conductance increases with dilution because the increase in volume is much more than the decrease in the kappa. Yes or no?
Yes.
Yes, sir.
The number of gram equivalent is equal to kappa into volume V. The kappa decreases and the volume increases. Again, molar equivalent conductance also increases with the dilution. Equivalent conductance increases with dilution. Okay, understood, everyone? Radhavika?
Yes.
So, kappa decreases, but molar conductance increases, equivalent conductance increases with dilution. Any doubt?
No, sir.
This today we have discussed the qualitative aspect, that means how will it decrease or increase. In tomorrow's class, we'll discuss quantitatively how much increase or decrease. Particularly, we'll discuss on the molar conductance. Right? Any doubt till now?
Yes, sir. No, sir.
No doubt.
No, sir.
Right. चलिए आज हम क्लास यहीं पर ऑफ करेंगे. नेक्स्ट क्लास थोड़ी लंबी चलेगी, हमारा नेक्स्ट टॉपिक स्टार्ट होगा, लंबा चलेगा. इट इज बेस्ड अपॉन द mathematical part of the variation of the molar conductance. Right? So कल ही start करेंगे sharp at 9:30. Don't get late. Right? And जो मैंने homework दिया that must be there. 5 questions on
Yes,
each
sir.
formula. Right? Okay then. See you tomorrow.
Thank you, sir.
Yes, sir.